Good morning, friends. Now we are discussing the derivation of Orifice Meter in module number 3 of the subject Fluid Mechanics under Fluid Dynamics. So Orifice Meter. So compared to Venturi meter, in Orifice meter, we have sudden change in the diameter of the flow. So we are fitting a circular plate having a hole, concentric hole. So that is the center of the hole is exactly the same as the center of the pipe. So all of a sudden the flow is reduced to a smaller diameter here. So if you see the sketch of the Orifice meter, now I can say P1 is the pressure at section 1, V1 is velocity at section 1, small a1 that is area of the pipe at section 1. So we have P2, V2 and A2 are corresponding values at section 2. So there is sudden decrease in the diameter of the flow. So to measure the energy loss, that is given in the form of difference in the mercury levels in the differential manometer. The manometer one end is connected at section 1, the other end of the manometer is connected at section 2. So the pressure change at these two sections will be measured by difference in the levels of mercury, that is given here as X. Now applying Bernoulli's equation of motion at both these sections 1 and 2. So we have sum of the three heads, pressure head plus kinetic head plus datum head at section 1 will be equal to sum of the three heads at section 2. Now grouping the terms on one side, P1 by rho g plus Z1, then taking these two quantities on the other side, they becomes minus, then taking V1 square by 2g on the other side. So just rearranging the terms. So here Z1 and Z2, they are equal, so they get cancelled because the pipe is laid horizontal. Whether I take the point here or here at these two sections 1 and 2, they are at the same height. So this is Z1 and this is Z2. So both are same. So they are getting cancelled. So P1 by rho g is pressure head at section 1. P2 by rho g is the pressure head at section 2. So H1 minus H2, that is the differential head H. So this is now H on the left hand side. It is V square by 2g minus V1 square by 2g. So taking LCM and cross multiply, 2gh is equal to V2 square minus V1 square. So taking V1 square on the other side, it becomes plus V1 square. So V2 is now expressed as V1 square. Now section 2 is at vena contracta. So now section 2 is at vena contracta. So A2 is now area at the vena contracta here. So A0 is the area of the orifice. We have one more coefficient here called as coefficient of contraction. So that is given as area at vena contracta to area of the orifice. So coefficient of contraction CC is the ratio of area at vena contracta to area of the orifice, A2 by A0. So A2 is A0 into CC. So we have the continuity equation A1 V1 is equal to A2 V2. So from this we can write V1 as A2 V2 divided by A1. So rewriting V1 in terms of V2. So now we know A2 as A naught into Cc, that is substituted. In place of A2 we are substituting A naught into Cc. Now we are getting V1 in terms of V2. So in place of V1 we are substituting this. So we have V2 is equal to square root of 2GH plus V1 square. So in place of V1 we are taking this quantity, squaring it. Now V2 square. So squaring on both sides, it is square root of 2GH whole square. So that is 2GH. So then a square root of this quantity to the power of 2. So the square root is removed there. So then we have here, so rearranging the terms. So 2GH is on one side and taking this plus quantity to the other side, it becomes minus. So both the terms have V2 square common, taking V2 square outside. So it is simplified to get V2 like this. Now discharge Q, either it will be taken as the product of A1 V1 or A2 V2. Now V2 is expressed in terms of an equation, so that is substituted back into the discharge equation, and we know A2. So A2 is taken as A naught into Cc, that is also substituted. So substituting both V2 and A2 back into the discharge equation, Q is equal to A2 V2. Now we have here, so coefficient of discharge, so that is given as coefficient of contraction, and simplifying this coefficient of contraction and coefficient of discharge. So the equation of Q, that is discharge equation, will be expressed as CD into A naught into A1 into square root of 2GH divided by square root of A1 square minus A naught square, where CD is coefficient of discharge for the orifice meter. So since compared to Venturi meter, in case of orifice meter, so the energy loss is more, so the coefficient of discharge is less compared to the CD value in the case of Venturi meter. So that is, the CD of orifice meter is less than the CD of Venturi meter. So CD value of Venturi meter is somewhere between 0.85 to 0.95. So in the case of orifice meter, it is less than 0.85. Thank you, friends.